Welcome to my video series. Today is part 10 of the chapter Theory of Quadratic Equation, and it is for preparation of JEE Main and Advanced and for different state level joint entrance examination. First problem today is problem number 48, and it is actually the problem is if one root of x square plus 9x plus a is equal to 0 is minus 2 and x square plus ax plus b is equal to 0 have equal roots, then value of b minus a. Options 35, 10, 48 and 33. Here two quadratic equations are given. One is x square plus 9x plus a is equal to 0. One of its roots is minus 2. And the second quadratic equation is x square plus ax plus b is equal to 0, given that it has equal roots. Oh, sorry, just 1 minute. It has equal roots. Then under these conditions, the value of b minus a option is there. As because minus 2 is a root of that, it must satisfy it. Therefore, minus 2 whole square, that is 4 minus 18 plus a is equal to 0. So a is equal to minus 14, so it is 14. And from the first equation we get value of a, and this equation have equal roots. So b square is equal to 4ac. That is, a square means 14 into 14 is equal to 4b. That is, b is equal to 4 cancels, 2 cancels with that, 2 cancels with that, 7 into 7. b is equal to 49. So we obtain a and b. So b minus a is equal to this minus 14. So 5, 35. So 35 is our answer. Now this is about the first problem. Second problem is problem number 49. It is just 1 minute. If m and n are real, m and n both are real, and 2 plus root 3i is a root of x square minus mx plus n is equal to 0, then value of m square plus n square. Options 13, 41, 65 and 41. Oh, 41 is already, oh, just 1 minute. It is 43. Acha. Here m and n are real. So this equation have real coefficients. One root is this 2 plus root 3i complex number. So its other root must be its conjugate. So 2 plus root 3i and 2 minus root 3i are its two roots. From this information, sum of the roots must be equal to m. Sum of the roots is m. So 2 plus root 3i plus 2 minus root 3i is equal to m by 1. So m is equal to 4. Cancels. Similarly, product of the roots is n. So n is equal to product of the roots means this into that. So it is 4 minus root 3i into root 3i. So 3i square is equal to 7. So we obtain again m and n. So the value of m square plus n square is equal to 16 plus 49 is equal to 565. So option C is correct. Next problem. Oh, sorry. It was 49th problem. Now it is 50th problem. Problem number 50. Problem is the range of P such that roots of such that roots of 3x square plus 2x plus p square plus p minus 2 is equal to 0 are of opposite sign. Now we have to find the range of p for which this equation have roots are of opposite sign. If roots are opposite sign, one must be positive and one must be negative. So their product must be negative. Their sum may be positive, may be negative, may be 0, but product of the roots must be negative. But here, product of the root is p square plus p minus 2 by 3. Product of the roots is c by a. This must be negative. Now, 3 will be absorbed here. It is actually equal to p minus 2 into p p plus 2 into p minus 1, p square plus p hai. Okay. So this is negative. So under that condition, we have to find the range of p. Actually, p minus, suppose this is minus 2 and this is plus 1. If p is greater than 1, this is positive, this is positive. So not satisfied. So p cannot be there. If p is less than minus 2, say minus 3, then it is negative, it is negative. Product must be positive. So P is not there. But if P lies between -2 and 1, say 0, then this must be positive and this must be negative. So P lies within that interval. Therefore, -2 less than P less than 1. This is our answer. Oh, option, I have forgotten to give the option, and one option must be that. Next, problem number 51. 51. If alpha beta are roots of px square plus qx plus r is equal to 0 and p square plus 3pq plus qr is equal to 0, then the value of alpha plus beta into 3 plus alpha beta is equal to options 4, 3, 6, 1. Here, one quadratic equation is given. Px square plus qx plus r is equal to 0 and alpha beta are its roots. Then the value of that. Oh, one more thing. This is also given. Relation between coefficients. The from here, before that, we are given that alpha plus beta is equal to minus q by p, and alpha into beta is equal to r by p. Now, dividing both sides by p square is 1 plus 3 q by p plus qr by p square, that is q by p into r by p is equal to 0. Now 1, q by p is alpha plus minus alpha plus beta. Again q by p minus alpha plus beta into r by p is alpha beta. So that we have 3 alpha plus beta plus alpha beta into alpha plus beta is equal to 1. Taking this into that side, this is 1. So alpha plus beta taking common, we have 3 plus alpha beta is equal to 1. So required uh, expression is this, alpha plus beta, and its value is 1. So option D is correct here. Next problem. Problem number 52. Problem number 52 is, if roots of 52, if roots of x square minus 2cx plus ab is equal to 0 are real and unequal, real and unequal, then roots of x square minus 2 into a plus b into x plus a square plus b square plus 2c square is equal to 0 are options: all positive, all negative, imaginary, one positive and one negative. Here, given this quadratic equation and given that its roots are real and unequal. If roots are real and unequal, then discriminant must be positive. If real and equal, discriminant will be delta will be 0. So in this case, delta is positive. That is 4c square is greater than 4a means 1, 4ab. That is c square is greater than ab. Now we have to find the nature of roots of that. So its discriminant d is actually equal to 4 into b square, 4 into a plus b whole square, b square minus 4 into a is this, c is that. Taking 4 common, a square plus b square plus 2ab minus a square minus b square minus 2c square. So a square b square cancels. So we have taking 2 common, again common here, 8 into ab minus c square. But c square is greater than ab. So ab is less than c square. So it is negative. So value of the discriminant d or delta is negative. Therefore, roots of that are imaginary. Next problem, 53. Problem number 53. If product of roots of x square minus 3kx plus 2 into e to the power 2 log k minus 1 is 7 and roots are real, then value of k is options: 4 plus minus 2, 3 and 2. Here one quadratic equation is given. This, oh sorry, this is equal to 0. The then given that its product of the roots is, sorry, 1 minute. Given that product of roots of that is 7, product, and roots are real, then value of k. The equation actually is x square minus 3kx plus 2 e to the power log k square minus 1 is equal to 0. Now e to the power log will balance, so it is equal to x square minus 3kx plus 2k square minus 1 is equal to 0. One thing, roots are real, so log k must be real. All are real, k is real, 1, 3, all are real. So k, log k square must be real. Log k square, it is actually when k is equal to log k, it is real, so k must be positive. Mind that, this is a trick. Log k is positive. Now, as because, so now we have k is positive. This thing to be keep in mind. Now, product of the roots is 2k square minus 1, given that it is 7. So 2k square is equal to 8. K square is equal to 4. So k is equal to plus minus 2. But k minus 2 is inadmissible here. Only 2 is. So our option D is correct. Okay, let us stop today. Next day, from next day, I will discuss few long type problems. Today's, so I request you to subscribe my channel, like and share, also share my channel. Thank you.